So, this is Algebra 1, Unit 6, Lesson 4 continued. And in these examples, we are going to write equations in slope-intercept form. For examples 5, and then on to the U-try. So for example 5, it says, write the equation to the given graph. The first thing we need to do is find the y-intercept. To remind you what the y-intercept is, first of all, in our slope-intercept form, it's b. And most importantly, to find it on the graph, it is where the graph crosses the y-axis. Looking at our graph to the right, the linear function crosses the y-axis at positive 2. Remember, the y-axis is the vertical axis. So our y-intercept is not just 2, it's the ordered pair 0, 2. That is on the y-axis, so the 2 goes in the y coordinate spot. The next thing we're going to do is we're going to identify the slope of the graph. We can do that using the counting method, or we can do that by using the slope formula. Here it's having us use the slope formula. So what I'm going to do is I'm going to pick another, what I'm going to call perfect ordered pair on this line. Okay? When I say perfect, I mean an ordered pair that crosses at an intersection of 4 corners. There's actually several I could pick. I could pick this ordered pair. I could pick this ordered pair. I could pick this ordered pair. And there's many more. I'm going to pick 2 of these ordered pairs. One of those ordered pairs could be the y-intercept that I have written in step 1. For this purpose, I am going to pick -1, +1, and I am going to pick +1, 3. So the skill you need to know for this step in itself is how to read a coordinate plane and how to name ordered pairs. It doesn't matter which 2 ordered pairs that you pick on the linear function, we should get the same slope regardless. It may mean you have to reduce differently than I reduce here. It may mean you have to take care of some negative issues or simplify negative issues, but we should get the same slope. I'm going to label my ordered pair x1, y1, x2, y2, and I'm going to plug into the slope formula. I like the method where I draw my fraction bar and my 2 minus signs. And now let's plug in the appropriate numbers. y2 is the y from my second ordered pair, which is 3. y1 is the y from my first ordered pair, which is 1. Now for our x's. x2 is the x coordinate from my second ordered pair, which is 1. And x1 is the x coordinate of my first ordered pair, which is -1. My numerator simplifies to 2. My denominator, minus a negative, becomes plus a positive, and it simplifies to 2. This now equals 2 over 2 can reduce to 1 over 1, or simply 1. So my slope of this line is 1. If you prefer to write it 1 over 1, that's fine too. And let me remind you that the slope is represented by the letter m. What we need in order to write slope-intercept form is we need what we already have. We need m and we need a b. So we just found the 2 things we need to write the equation of this line. The slope m and the y-intercept b. So I'm going to go ahead and I'm going to replace m with what I found the slope to be, which happens to be positive 1. And I'm going to substitute b to be what I found my y-intercept to be, which is positive 2. Because the slope here is 1, I can go ahead and make that invisible, because coefficients of 1 can be invisible. And it turns out the equation of this particular line is y equals x plus 2. Your job right now is to hit pause, try the U-try, and then hit play again so you can check and see if you got the U-try correct. Alright, so at this point you guys should have the U-try completed, and I'm going to go ahead and complete the U-try and you can see if you got it correct. The first step is finding our b, or our y-intercept, and this linear function crosses the y-axis at positive 2, which is the ordered pair 0, 2. Identify the slope, so I need to identify 2 ordered pairs, perfect ordered pairs. I could go ahead and use the y-intercept if I'd like. I'm going to use this ordered pair, which is at negative 1, positive 1, 2, 3, 4. So negative 1, positive 4. And I'm going to use this ordered pair, which is at positive 2, negative 2. It doesn't matter which ordered pairs we pick. I made sure I picked perfect ordered pairs, so for ordered pairs that have an integer in the x coordinate, integer in the y. So they cross at a perfect four-way stop, or a perfect intersection. Label my, let me zoom in a little bit, label my ordered pairs x1, y1, x2, y2, and now plug into the slope formula. Draw your line with your 2 minus signs. y2 is negative 2, y1 is 4, x2 is 2, and x1 is negative 1. My numerator simplifies to negative 6. My denominator simplifies to 3. And negative 6 over 3 reduces to negative 2 over 1, or plain negative 2. So my slope is negative 2, and that is valuable because it is m, and I'm going to substitute it in for m into writing this equation in slope-intercept form. To remind you to write an equation in slope-intercept form, we need an m, which we found in step 2, and we need a b, which is the y-intercept, which we found in step 1. I'm going to replace m with what it equals, and it happens to equal negative 2. Then we still have our x, and then b, our y-intercept, is 2. I'm going to substitute positive 2 or plus 2 in for b. Check your answer at this time. You should have gotten y equals negative 2x plus 2. If you did not, please see your teacher and get help if you cannot find your own mistake. This concludes Unit 6, Lesson 4, writing the equation of a line in slope-intercept form from a graph.